Hi everyone, I'm Miss B, this is Mr. K. We are going to be doing a flux core demonstration for you guys today. FCAW, flux core arc welding, also known as flux. We showed you yesterday how to do a wire changeover, so today we put a different type of wire on there. We're using E71T-1, so your chemical codes and compositions, your electrodes, 70,000 tensile strength, 1 for all positions. T for your tubular wire, and then your chemical makeup, your last one. We're going to do a demonstration as far as showing you what flux core will look like with and without gas, too high a heat, too low a heat, too high wire feed speed, things like that. And Mr. K and I will both show you some good techniques, some bad techniques, how those welds look like, what they're supposed to look like. We're going to start with padded plates and probably go right into T-joints and lap joints. Alright, so we are using a mild steel plate. As you can see, there is some mill scale on here. I did not clean it off at all. It's not really going to cause an issue for us for what we're doing today for demonstration purposes. This is a slag process, so you should know that slag you drag. So I'm going to be using a backhand technique. So if you are a right-handed welder, you're going to weld left to right. If you are a left-handed welder, you would be welding right to left. So for instance, just to show you setup, camera here, I would be welding left to right in this position, nice drag angle, watching my contact tip to work distance, of course. Okay. So let's get started and run a bead. One of the things you'll notice is the slag on top of the weld here. We'll go ahead and chip that off. Okay. Brush that. I really ran mine right on the edge of that plate, so not the prettiest. You can see how the edge got kind of burned away here. Okay. I'm going to run another one right down at the toe of that weld as if I was doing a pad plate. Turn this angle for you. We're going to make that wire touch right at the toe. If you notice when I stop, instead of cutting my arc out on the very edge of that plate, I kind of go back into my puddle. The reason for that is if you just stop and let off of the trigger, you're going to get a small crater. We don't want to have craters. We can have cracking that develops in there. That part can become weak. We can get a crack throughout the entire weld. So if you just do a little bit of a back step into it, you will throw that crater in. Slag comes off pretty nice. I'm really not hitting it that hard. A little piece right here. As you can see, I ran that second pass right along the toe. You can see a nice smooth transition all the way down. Okay. Still using that backhand technique, good arc length. But let's show you what it looks like if we try to push our weld puddle instead of drag our weld puddle, and show you how the face of that weld will turn out. So I'm going to start in the opposite direction, just for the demonstration purposes to show you how to make that push as if we were using MIG.
Here we go.
Again, I did that pause, that slight back step on my crater. So Tom, what's happening when I'm pushing my flux core instead of dragging it?
When we're pushing it, we're actually pushing the fluxes in front of the weld. So then what we end up with, as we're welding, we're going to end up possibly getting slag in front of the weld, and then it'll get slag entrapment possibly. When we're pushing it, we're going to cut back on penetration. We get flatter profile on our beads, yet we need to worry about our penetration, no slag getting in the weld, and we want a little bit of reinforcement on our welds, so when we drag it, we get our penetration, we get our reinforcement, and a nice contour to our welds.
One of the things that before I added this third pass where I was pushing that we didn't have before, we didn't have all these little BBs, okay, or weld spatter on there. So what are some things that cause weld spatter?
Technique, as far as our stick out for our wire too far, gets us spatter. Our angles, whether we should be around 15 to 20 degree drag angle, that keeps the spatter down a little bit. If we angle it a little more, we end up with a little more spatter. Our parameters, welding out of parameters definitely gives us more spatter. Gas coverage, a lot of different things we have in there that works into how much spatter we get.
So if I have too much wire feed speed, I could just turn it down and probably control it that way.
Yes. Sometimes we can turn volts up, volts down, wire feed up, down. We can dial it in and get exactly what we want with minimal spatter.
All right, and what are our typical settings for this process on this 3/8 plate?
My guess, without looking at the wire guide, normally we should consult the manufacturer's specification, but we're going to be around 23, 24 volts with this. Wire feed depends on the machine, but we want to get into an amperage range of about, what, 160 amps, somewhere around there, 140, 160 amps.
So right now, just so you guys know, I have the machine set at 25 volts and 295 wire feed speed. That's what we're running, but I want to show you some good things and some bad things. So I started off showing you a couple of good things, and then I started working with the technique. But what I'm going to do now is I'm actually going to turn that wire way down. I'm going to go down to about 20 volts, which is well outside of the normal parameters. And I'm going to leave the wire feed speed the same at 295 and kind of just show you the different effects that it has. Hopefully we won't ruin any contact tips. All right, all I did here was turn down my volts by 5. I'm still going to use that backhand technique. I'm still going to drag. I am a right-handed welder, so I am going to weld left to right. Here we go. So definitely some issues along the way. Even felt as far as like the wire was getting stuck and wasn't letting me move. I was kind of feeling it a lot in the handle. Something else you're gonna notice is the slag is a lot harder to get off. A lot of very noticeable changes. So, Tom, what's going on with my plate here?
What we're getting is too much wire feed for our voltage, and we're getting a lot of buildup. We have excessive reinforcement. So if we look at it, we're usually allowed an 1/8 inch of reinforcement. So when we look at this and turn it where we can look down it, you're going to see we have well over an 1/8 inch reinforcement. These have a nice profile. Even though her technique was okay for her drag, the wire feed was too high for the voltage, and that gives us excessive buildup, excessive reinforcement. And once our toes hit 90 degrees, we end up with overlap. Overlap causes a high stress at the weld toes, and then we could end up with cracking if we were actually using that on a job.
And something else you'll see is I definitely have a lot more spatter on the plate. What should we try next?
Fillet.
All right, on this I'm just gonna run a regular 2F plate. I'm gonna tack them on the outsides of my plate.
Do you want to turn your voltage up?
So when we're talking about positions, we have 4 main positions. We have a 1F, which is a flat position, which would actually be like this, turned up, weld angle like this. Okay. We have a 2F, which is our horizontal, welding in this position. We have a 3F, which is our vertical, and we would be welding upwards or downwards, depending on what process and procedure we're using. And then, of course, we have our overhead position. Our 4F position would be like this, and we would be welding underneath. Okay. So let's go ahead and run a 2F. I've already got my plates tacked up, and I'm gonna drag. What I'm going to do here is I'm actually going to stop in the middle to show you guys this crater that I left, and I'm going to do a tie-in in the very center and then continue welding all the way out so you can kind of see what that looks like. You'll see between my angle and everything that my toes are pretty equal on both sides of my plate. I have a small crater right here, all right? I'm actually going to start my weld right here. I'm not going to start on the very end, otherwise I'm not going to be able to fill that crater in. I did not do a back step when I stopped. I purposely left that crater there. Normally I would clean that out, I would grind that out back into the base metal, and then I would go ahead and restart my weld, but just for practicing in here, I'm going to show you how to do these little tie-ins. I'm also going to do that back step on the very end when I stop. Wire here. All right, here we go. Did that slight pause. And you can see a very smooth transition with my tie-in. So if we were actually to put a gauge on there, it's going to be the same size, all right? And you can see there's no crater on my stop. I did that back step. All right, if I want to go ahead and put make this a multi-pass fillet weld, we're going to add passes 2 and 3. I'm actually going to start number 2 on the bottom toe. I never want to start on the top. Why would that be?
Just for gravity. You start on the top, then you start working your way down, you end up with slag entrapment. So we always want to start at the bottom and work our way up. And another thing to remember, in this position and overhead position and where it's horizontal overhead, we want to run stringers. We don't want to run any kind of weaves. We can run a little manipulation with our wire, but no weaves in this position or any position that's in the horizontal. So our vertical and our 1G, 3G, we can actually run mobile pass and weave or stringer, but our 2F and our 4F, we run stringers only.
All right, so let's go ahead and run our second pass. I'm only going to do it about halfway to right where that tie-in is. Maybe a little bit more, just so you guys can see the transition between all of the passes. All right, there we go. And I did do a slight back step there as well. Pause. Slag comes off real nice. Okay. Just want to be able to show you the transition here. Okay. You can very clearly see the toe of the first weld here and the toe of the second weld here. Okay. I'm going to go ahead and place that third weld. I'm going to aim for that first toe on the top. I am not going to aim at the toe of the second. Okay, otherwise my weld is going to be too far down. I need to make sure that I make it 50-50 between the two plates. Okay, so I'm going to go ahead and add that third pass on. Here we go. Stop just short of that second pass so that I can actually show you the transition between all three. Good. Okay. You can see all three passes. Here's my first one. Here's pass number 2, pass number 3. Now why don't we get out those fillet gauges that we had. Pause this for just a second.
Okay, the biggest thing is engineering. When they design a product, they figure out the size of the weld that they need to actually get a product that's going to be strong enough to hold up in the field, and we don't want to add too much wire where we spend more money on wire. So they'll come up with a weld size to strength to our products to make sure that we don't over weld it. So whenever we get to doing fillet welds, we get fillet gauges. I'll show them a little closer when we switch cameras. And then we actually, if the print says we need 3/8 welds, like this is what we have, 3 passes, I would pull up my gauges. I'd find maybe the 5/16 to 3/8 and then go from there. Then I'd check them and go off of that. But the proper weld size is very important because we're controlling warpage, distortion, heat input on our part. So if we overheat the part, we can damage the materials. So we're always looking to follow the prints, make sure our weld sizes are close. Usually we can be pretty much right on, but we don't want to be any smaller. Anytime we're reading a gauge, We don't want to put it on a part and have light underneath the edges of the gauge. Biggest thing with these gauges, I'll switch over. Biggest thing with these gauges here, these edges need to be sharp. We need to keep them in good shape. We don't want to use them to scrape any slag off or anything, because we want to be able to have these gauges calibrated if we're actually in a shop where we need to use them as a calibrated tool. And so our corners need to be sharp. Biggest thing is we want to look at first is the contour of the weld. So when we look at it like this, we're going to see the face of the weld is pretty flat, so we can actually use the actual fillet weld. There's two different styles of gauges here. There's one for the fillet weld leg lengths, and then there's the side for the throat size to give us the actual size of the weld. You got to remember, if we have a shallow weld and it's concave, we use this size. The legs could be 5/8, but the actual weld size could be 3/8. So we want to use the correct side for the weld that we're working with. So we have a 3/8 here. What I'll do to see if it's, my guess is correct, okay, it's a little larger than 3/8 off of there. And we'd fit it here, and from there you'd see it's a little under 3/8 on there. Then we'll switch it over. I'm going to try the concave contour gauge. That's putting us in the area. So now I'm going to find the actual size of the legs. Let's see, it's not 3/8. It's under half. So anytime we're working with this, we can find the correct gauge to figure out which size it actually is. But working off the concave fillet, being that this is pretty flat, it's given us that it's a 3/8 weld in there. Okay. So the lower leg is 7/16. Upper leg is going to be like 5/16. So we got 5/16 weld there.
We hope you guys enjoyed the video. We incorporated the welding gauges. We showed you guys a new process, how to kind of set up the machine yesterday, and then again, making that process today. So a couple of key features. Just remember that this is a tubular wire. We were using 045 Lincoln Electric E71T-1 wire, and 25 volts and 295 wire feet speed is about where we were running it, using a backhand technique. And I thank you for showing us how to use the gauges today.
Yeah, and just remember, we covered the basics. There's a lot more to it than what we covered. It's just a matter of getting you a good start for when we start the FCAW process.
Can't wait to have you all back in class so we can do it in person.